Hi, here's the last two videos for section 8.1 practice problems. And finally, after the first three, we get to a discrete random variable. I can tell because there's only a discrete number of options. Let's see here. An advisor looks over his schedule he has 50 advisees, and he wants to see how many math and science classes they're taking. And X, I'm just going to put here, over here, this is science. And Y is the number of math classes. And all 50 are incorporated into this matrix, a nice table here. So the random variable X is the number of science classes his advisees are taking, 0, 1, or 2, math 0, 1, or 2. So here's the joint density function within this matrix. So the first couple of problems we could answer pretty much from the table without building any mask functions. So what's the probability that we randomly choose one of his advisees and they are taking 2 math classes? So I just go over here in this column. Here's 2 math classes. I sum over all the possibilities for the sciences. So I'm summing y equals 2 over x equals 0, 1, or 2. So I can hardly see the number that I put here. This is 7, 8, 9, so this should be 9 over 50. Okay, so next one, what is the probability that an advisee selected at random is taking one science course? So science is x, so when x is equal to 1, I sum over my y's. So this is 19, 22, 22 over 50. Okay, what's the probability that an advisee selected at random is taking 2 math classes? So y equal 2 and x equal 1. So let me see, y equals 2 is here and x equal 1 is here. So right there, that's 4 out of 50. Letter number D, I put on homework set 6, and E, maybe we'll build the marginal for one of them. So let's look at, let's just look at f of x. So f of x can take on the discrete values 0, 1, or 2. So when x equals 0, I sum across my y's. So this is 21 over 50. When x is equal 1, I sum over my y's. So this is 22 over 50. And the last one, this is 7 over 50. This should add up to 1, all these probabilities. And they do, right? The sum of f of x over x equals 0 to 2 is equal to 1. This is a valid mass function. We could find expected value now, right? Just f of x times x and sum of x times x, f of x times x. We could sum that up. Finding f of y is the same way, except I'm going to look at y equals 0 and then sum over my x's, y equals 1. So we're going to get f of y in the same way. So I think just determining the marginal for x here will be fine. And I have one more video to make for problem 5.